Thank you very much for that introduction. My name is Darrin Bryant, and I will be your presenter. It's really good to see all of you in attendance, and yes, there will be a question and answer session at the end of the presentation. But without further ado, let's get started. Today we're going to be talking about how to overcome multi-channel mill-turn and Swiss-type CAM programming using SolidCAM inside SolidWorks, a single window integration solution. Now I'm going to primarily focus on the Nomura NN32YB3XB, which is what you're looking at right now. It is a 5-axis, 2-channel machine. These two views on the left are two different views of the main. Upper right is a view of the sub, and then we have one from underneath to show both channels running. This is the machine we're going to focus on. You're going to see a lot of things throughout today, all the way from starting a project to setup sheets. And you're going to see that inside the single window integration. Some of you might be out there creating a part inside of a CAD and transferring it to the CAM and back and forth again to do revisions, to update the toolpath. Some of you may get associativity, maybe you don't get any, or maybe it breaks it completely and you have to redo the part. That doesn't happen in SolidCAM. We're staying within that window, as you will see throughout this entire process, with everything that I do. You're going to need a really good post processor. Some of you might have some post processors that you were guaranteed that were out of the box or certified, yet they're still not working, or maybe you haven't gotten yours at all. Maybe that'll work fine for 3-axis Haas, but when it comes to these more complex and increasingly more complex CNC machines, you're going to need a good post support and post people behind you. Now, this particular post was built by Eric Forwith, one of our many in-house post-processor writers. But you can also edit these posts or create them yourselves. We're also going to take a look at some iMachining. If you haven't heard that word, get familiar with it. It is revolutionizing the way we cut metal. It is patented. We have 7 patents on it. Came out about a decade ago. There are a lot of other CAM companies that have tried to copy what we've produced. But it shines in 3 areas for you: bulk material removal, exotic materials, or tiny tools. It'll do 3 things for you right off the bat. It'll program faster. Your cycle times will be starting at about a 70% reduction in cycle time and much higher, provided you're cutting aluminum or harder. And you're going to preserve your tool life at the same time. And I'm not talking 1 or 2 or 3 times. I boast 5, 6, 7. Some of our customers are claiming 10 times tool life increase. So there's a lot of benefits to be had using SolidCAM, as you will see today. Let's go ahead and go to one view so you can kind of see the internals of this guy and what we're looking at here. There we are. That's a little better. But let's go ahead and start a new CAM project from scratch so you can see how you start a project and just how easy it actually is in here. So let's go ahead and open up a SolidWorks file. However, it does not need to be a SolidWorks file. Pretty much any format in the industry, SolidWorks supports, and they have amazing translators. Now, this could be a simple DXF or DWG or a simple sketch, but we also work on STL graphics files. Pretty much anything you can get into the system, we're going to be able to cut. But let's go ahead and open up this King. Now, at first glance, you can see that I put in my stock and my part. Generally, you're just going to start with your part, but I like to be a little more visual in presentations so you can kind of see what we're working with as far as the stock. The stock can be created when you start the project. I'll show you that here in just a minute. Now, I generally like to make my stock 10 thousandths over on the part because there's no need to make the super long stock. Otherwise, your stock would be long and your part would be small on the screen. It'd probably look something like this with a long stock. So, also, I can use these values later on when I'm setting up different distances and stuff like that inside the Swiss machine. So now in this particular model, I do have some detail, neck detail, that I use custom cutters with. So that's the Rev 1 without the stock, Rev 2, and Rev 3. But I can also change any of the features in here at any time after programming my part and update my toolpath, which we will definitely take a look at. But let's go ahead and start a project. There are 4 ways to do that. You can start from the tools up here, and we would go into mill turn. There's milling STL. You could do it from the tabs. You can do it from the ribbon, or you can open up a project or start a project from here. And we're going to go ahead and do mill turn. Now on a fresh install, you actually won't see this window, but I like to show all my windows because there's 2 ways to run a project. With internal, you can embed all the CAM project files directly into the SolidWorks file. External will keep them separated. Now it does that by making a perfect copy of the original file, putting the original file away for safekeeping, and we work on the reference file that's always in perfect reference to the original. So if we do go back and make a change on the original file, it's going to push those changes down to this reference file and update our toolpath, and you'll see that as we go along. So I'm just going to go ahead and select OK here, and it's going to go ahead and go through that process of making a perfect copy of the original file, putting the original file away for safekeeping, and then bringing us to the main area where we start our project. And this, by the way, is what every project looks like, whether you're doing probing, 2, 3, 4, 5-axis, mill turn, or Swiss. So there are 4 parameters we need to fill out for any given project. First is going to be your post, and this can be a simple default to whatever machine that you use most. We're going to go ahead and grab the Nomura 5-axis. Now this does more than just generate your code. It dictates what you can and can't do, like coolant options, can cycles, kinematics. It's very important. Now, can you switch your post later on? Let's say you're doing a, I don't know, 5-axis project and that machine happens to be busy. Can you come back and switch it to another 5-axis or even a 3-axis machine? Yes, you may have to adjust a few toolpaths, but you can do that at any time. But let's go ahead and create a coordinate system because that'll be the next thing we need to do. There's lots of ways to do that. In a turning project like turning, mill turn, or Swiss, you're always picking for the main spindle. So I'm going to leave it on a selective associative face. I have it set to go around the center of my revolve, so I can pick any surface that's revolved and pick it. Now, it picked for the main spindle, but if I want to rotate this around and have that sticking out of the main, I can simply change to opposite. But you're always picking for the main spindle. Now, because we know the machine and that's what we picked first, it actually created the subcoordinate system for me. Stock and target, very important. So let's go ahead and go into the stock. Now, I've already drawn my stock in here, as you've seen, but there's a lot of ways to develop your stock. That's why you don't have to develop your stock in the beginning. You can do it right here. You can also pull that from the configurations. So let's say I'm working with a different configuration with a longer king. Well, I can develop that stock to be associative to the part. So if the part changes sizes, the stock changes sizes, and it gives me that extra 10 thousandths per side, which is really nice. But we're going to leave it on here, and we're going to simply pick the stock as a 3D model. And of course, you can show that if you like. There's the stock I'm working with. We'll go ahead and select OK here. It is going to parse the model, which basically is rotating that solid and creating a silhouette snapshot of what the stock looks like while it's turning. Now, target's going to do the same thing. So we'll go ahead and pick the target, select OK. It'll say parsing the model. It's spinning or revolving the part and creating a silhouette snapshot of the turning profile. Maybe you've got a boss sticking off the side. You don't want to accidentally cut that off. It will see that and show you. Now, you can also use the wireframe to cut from. You can develop your toolpath from using the wireframe, or you can do it from the solids. Personally, I like to use the solids, so I'm just going to simply hide that. It's not gone, just hidden. Now, I will keep around the stock here because I'm going to show you something about that when we get into it, but that's just for a visual. Let's go ahead and finalize this project. All right, so let's go here. At first glance, you're going to see the SolidCAM tree, and this is what the tree looks like for every discipline, whether you're doing 2, 3, 4, 5-axis, mill turn, Swiss. Now, everything that we just talked about and to set up the part is located up here. You can right click or double click and get right back in there, but we did break out the machine, coordinate, stock, and target, so you have easy access to those areas. As I mentioned in the beginning with those custom posts, you do have the ability to create your own. We have a GUI-based system to do that. You even have a preview window so you can see exactly what's happening, and you will see this preview window throughout the presentation today. It's very handy for all kinds of different things. So our toolkit is really going to revolutionize how you do tooling, from a simple end mill to a right angle head with multiple joint points and everything in between. Think of the toolkit as a toolbox, not a tool library, which is what a lot of CAM systems use. A tool library to us is a tool within that toolbox, okay? So let's work our way down the left-hand side and you'll see that. Now we have 4 different 1-hour videos on everything this can do, so I can't possibly touch on everything. But again, going back to that personalized demo, if you'd like to see one, just hook onto our website and ask for one. Now I keep all my windows on one screen. Most of you probably have 2, and you can move all these over to another screen. That way, when you're developing tools or putting them in there, you can have bigger windows, make it a little easier to see. This is your tool view, this is your machine view, okay? Starting over here on the left-hand side, let's start with an end mill. Now, you can highlight a position, and you can double-click it, or you can right-click it and send it somewhere, or you can drag and drop it over there. So I'm just going to drag that over to here. And then, of course, you can develop the size of your tool right here. 3 different ways to customize it. Parameter-driven data, which is what you're looking at. You can edit a 2D sketch, or you can bring in a 3D model. You can do things like 1 divided by 2, maybe 12 millimeter. You can switch from metric to inch or inch to metric. We're going to make a 1/8 tool. We'll do 3 times the diameter for the cut length. Stick it out an inch, and we'll give it 3 flutes because we're defaulted to aluminum right now. And again, if you want to see that position, there it is right there. Now, based on that, if I'd like to scroll that out, I could use my middle mouse button, or I could just simply type in a value, okay? Now, you do not need to come in here and pre-set up tools. You can just start programming your model, and when it asks for a tool, it'll actually bring you in here, and you can download your tool or pull it from a library or build it, and then move on, because the next time you grab that machine, you can elect to have all those tools come back in for that next project, or you can send it out as a specialized library. Up to you. Let's go ahead and go down to turning tools. We're going to go ahead and put one in the cutoff position, which is going to be number 6. So let's scroll over here. That's right up here. All right, that's our cutoff position. So let's go ahead and grab this one, and we'll drag it into position number 6. Now, real quick, I'm just going to make this 100 thousandths wide. That's what I generally use. But going back to the actual shank, I want a little more stick out here, so I'm going to make that 1 inch. And let's decide where we're going to put it. Now, I can go ahead and set that tip point right there at the connection point that we put on the tooling block. You can actually move that where you like it. If you want it automatically always an inch out here, you can do that. But we'll just scroll that out to about there. Good enough for me for now. And we're good to go. So that's going to be my cutoff position. Some of the other things you can do, obviously, you can develop your drills, your specialty items, probing, broaching, saws, right angle heads. You can download your favorite manufacturing tool libraries from the internet. You can go to Tool ISCAR Advisor and create a tool that you need, or download a tool directly to your library for a particular job. Or you could develop your own tools and holders right inside SolidWorks and import them directly into any given library. And again, you have a component library, which would be like a shank and insert, and then you have an assembly library where you would join those together. This insert goes into this shank, it can also go into this other shank, and so on and so forth. Then, of course, a machine sim library, which we've talked about a little bit right here, where you could take that assembly and place it inside of a machine, like a mill turn right angle head onto the turret, okay, just for instance. we will probably come back in here multiple times, but again, we have 4 1-hour videos on everything that this toolkit can do, so I can't possibly touch on everything it can do, and I have a certain limited amount of time, and I want to make sure that we get to all the really, really important stuff. So let's go ahead and save and exit that. Now, the last thing we might want to look at, but we don't have to, would be our setup. And let's go ahead and turn on the machine preview so you can see in here. We're actually talking about, the stock and the target here inside the main spindle. It's your spindle 1 using Mac 1 position 1. And then, of course, we have our spindle 2 or sub spindle. And I do have an extended nose collet using Mac 2. Now, if you'd like, you can do a pre-set up location. I'm just scrolling this out, and maybe we'll snap that into position. It looks like it's going to be close to 1 inch. So maybe I'll just type in 1 inch. And I can save that position to use and recall later as a setup location. But you really don't have to do anything in here. You can do that all within the MCO that we're going to talk about very shortly. Now, in a Swiss machine, and I purposely left this out because I wanted to talk about this first and develop my tool number 6. Although in this particular machine, generally that's where your cutoff tool is going to be in tool number 6. So we have that in position already. 2,000 RPMs at 2,000 cutting feet. Now, this is going to do your cutoff and set your 0 point for your Swiss machine. So our cutoff is done. I don't have to do that. That's going to be automatically put into the post code at the very beginning. Let's go ahead and take off the remaining 10 thousandths I left on the face of this part for finish. This is what all of our dialog boxes look like, whether you're doing probing all the way through Swiss. We call this the workflow window. Start at the top, work your way down, geometry tools, levels, technology, links. One of 4 different ways to calculate your toolpath, verification, and you can generate code for this particular toolpath. We have over 8,500 pictures in the product, so most of the stuff you're going to hover over or select is going to give you a visual. If it doesn't, you can use your question mark and pick something. It'll tell you all about it by the content sensitive help. Mac 1 or spindle 1 and sub spindle. We're going to do spindle 1. If I have a solid, I'm going to use solids, but you can go back and forth and use solids in wireframe. I'm going to say new. The green is a live representation of what the stock looks like right now. That'll continue to update as we put on toolpath. So we're going to cut this face right here, okay? And I'm going to go ahead and take a look at that. We want to go the other direction. So we'll go that direction. I'm going to start on the OD and go to the ID. We'll accept it. And I personally like to give my chains names for a couple different reasons. One, it shows up here. This is a face turning operation. I'll get rid of that. Main spindle, face. It also shows down here. Now in milling, this becomes way more handy because you can do it in here as well, but in milling, you're going to do it more often as you can edit these chains. Now you can always use your 3 dots here to highlight the chains you've created, or the show button to highlight the face or the geometry that you picked. But I just like to name them. Now as far as tools go, it's going to take us back into the library, and we do need to develop a face tool. So I'm going to go ahead and put it in position number 5, and we'll just drag one of these over here. Let's go ahead and do something a little more steep, because this will help me get the rest of my geometry. And let's just go right to here. Actually, I think this is going to be a 625. I believe that's what they are. So 625, and we'll make that 625. Let's go ahead and take a look at that real quick. That's where this comes in really handy. Yeah, I believe that's the right one, but let's go ahead and set that into 0 point. Yeah, it looks pretty good. Okay. Yep, there's 625. Okay, so let's go ahead and develop that insert as well. So we'll click on Profile, and you can literally pick it from a list. V, we'll just grab an N, M, let's go do a G, and we'll do like a, I don't know, this may be a little big, but 3, we'll do a 2, and maybe a 0.2 here. This one here, that'll be fine. So we have a V&MG 320.2, and if you'd like, again, you could also just type it in up here, by the way. I wanted to show you the drop downs. Go in here, and for that insert, we could say, well, this is working on the main spindle. it can technically do OD and face type work and maybe give it a little notation of what it is. So it shows up down here in your descriptions. Okay, I didn't do that with the other ones, but that's very handy to do. Let's go ahead and accept, well, actually, let's pull this out a little bit. So we'll take this insert and we'll move that out. Now you can also move this coordinate system out to where you want your tool to snap to if you'd like. I'm just going to bring this out a little bit so we got some length. And maybe back in one here. That looks pretty good. That'll be good enough for the face operation. So I'm going to go ahead and accept that. And we've just developed a tool right inside the toolpath. It just took us right into the toolkit, right back in here, and now we have our tool. This is just a retreat distance. It's really referring to this one, but you can have a custom safety point if you'd like. Now facing is very simple, so there's only one tab and you can do everything on the one page. Now in this particular case, we only have 10 thousandths on there, so I really don't need to do a rough. And we are doing a front face. We're just going to simply do a finish with cutter comp. Save and calculate, and there's my toolpath. If you'd like to take a look at that in a standard verification, we have quite a few of those. All of these can be mixed and matched in our SolidCAM simulators, but let's start with turning. I love this one because it's just very simple, easy to look at, and you can see what's happening. Okay, if you want to take it into Solid Verify, you can make the stock transparent, bring your part up underneath, and of course verify it. You can also use our new simulator by holding down the control button and taking you into a new one where you can actually take all those other ones that you just saw and create your own theme. Take options out of the different ones and create your own customized operation or verification. You can also embed this directly into SolidCAM window. I'm just hovering, by the way. And you can make it stationary, so you can make the tool stationary and the part rotating. There we go. And the part moving, actually. That's great for 3-axis machines. Let's go ahead and close this, though. So verification, I'm using Solid Verify a lot just because I just really like it. But the Solid Verify, the SolidCAM Solid Verify is far more advanced and it's going to give you a lot more things that you can do with it. So let's just run that one more time. All right, let's go ahead and close this. And we're good here, so we'll just go ahead and save and exit this. This little checkbox here turns your toolpath on and off. And you can do that with multiples. I think for the purposes of today, I'm going to throw on a milling operation so you can see that the milling and the turning, they're all the same. But it's not in the order that I did this originally. And then we're going to bring up the original part because there's a lot more stuff to show. A lot of our 2D toolpath can be wrapped around a cylinder like phase, profile, pocket, drilling, engraving. We're going to go ahead and wrap this slot around the cylinder here, but first we're going to start with a profile operation. Now this is one of the most versatile toolpaths you will use in a lot of different areas and a lot of different machines. Profile is very versatile. So let's select new, and we'll go ahead and give this a name. And because the geometry is physically wrapped in this case, you're going to want to select wrapped and what axis it's wrapped around. Otherwise, you would just be picking off of a flat plane. Go ahead and accept that. Tools, let's develop a quick tool here. This is a 65,000 slots we're going to need with a 5,000 tip radius. So we're going to use a bull nose and we'll make that a 16th. 5,000 tip, and this is also a 16th. And we'll make the arbor diameter 125. 250 for the flute length, shoulder length, and sticking out an inch. Let's go ahead and look at this. Looks good. We got a little tip radius on there. Looks good. So we'll go ahead and accept that. As far as the levels go, if I pick the OD of this slot, it's going to give me that value, and it's storing that persistent ID inside that field. And if I can pick the inside diameter, it's also going to tell me the depth that it's dropping from the top to the bottom of that slot. Now, what can you do with profile? It can be turned into a pocket by adding material to remove. It even comes with some pocket options. If you want more pocket options, open up a pocket, but you can rough and finish with the same tool or with different tools. You can turn this profile operation into a chamfer or a rest operation. A rest is just removing remaining stock from like a bigger corner of a pocket that you use to rough out. You had material left over in the corner because you used a bigger tool. Now you want to put in a smaller one. Rest material would just go in there and knock out the rest of the material in there. You can obviously cut on the right, the left, or the center of that geometry we just picked. And there's that geometry button for milling, just like we saw in turning. You can give it start and end extensions, which are in addition to lead in and lead outs. If you take a look over here, you can even do I call it a virtual cutter comp, but you can offset this inside or out, and it does work in conjunction with the cutter comp function. You can also start your tool wherever you want. So maybe I want to cut to the center or start at the center of that slot. But in this case, I'm going to start at the end. In links, I don't need a lead in and a lead out, so we'll just make the lead out the same as the lead in. But there's a lot of ways to get into that material. You can drill a hole and plunge, not really needed, and I think it's only like 25 thousandths deep. You can peck with a center cutting in mill, helical in, ram back and forth. Vertical arcs might be good in this particular case. But generally when I'm doing a slot, I like to use profile ramping, and you can turn that on by selecting helical and the amount you want it to drop per pass. Let's go ahead and call this wrap geometry or wrap column. And now I need to wrap that around the cylinder. So we're going to do a transform around 4-axis. We're going to include the original. I believe there's 12. So that'd be 30-degree angle, and we're going to add in 11 more because I already have the original. Save and calculate. And there are the wraps for the rest of that. So now let's open up the original part with all the toolpath on it, so we can take a look at MCOs, iMachining, verification, and setups. Let's close this, and we will bring up the complete part. There we are. Let's talk about iMachining that I mentioned in the beginning of this program. iMachining is a patented technology. We have 7 patents on it. As I mentioned before, it's guaranteed to reduce your cycle time, reduce your programming time, and preserve your tool life. And we do that by managing what's known as a cut angle throughout the entire cut at all times. Let me go here. It might be easier to see. So generally people are doing a step over in a lot of other CAM systems. You got your step over, but we're going to manage a minimum and a maximum cutting angle for this cut throughout the entire time. So think of it as like cutting in a straight line or removing all your corners from a part. Nobody cuts in a straight line, but this is what this technology does. So we have a slider bar that uses 9 different parameters to calculate all your feed speed, step downs, and step overs. If I decrease, and by the way, you got view 1, RPM, inches per minute, minimum, maximum step over. View 2 is feet per minute chip thickness and that cutting angle that we were talking about. And if you slide this up and down, how aggressive you want to cut it, it will work at level 8 out of the box, but you'll likely start between 3 and 5 just because you're going to want to know about it, get to know it and use it. But I guarantee you'll be up at level 8. You can change just about everything about this. The wizard is on, but you have a lot of values that you can change. For instance, let's say you didn't have enough cutting length on your tool. Well, it would know that because that is one of the parameters we're looking at. So it would automatically self-adjust that, increasing the radial depth of cut and decreasing the axial depth of cut. Let me show that again. Let me go back to automatic. See how it gets less, and we can even prove that by looking at that maximum cut angle. So let's look at view 2. You can see we're at 80 degrees. The one thing you won't be able to do over here is to go over 80 degrees because that's where the damage to the tool occurs. So we're not going to allow that. But let's go ahead and turn that off, and we're at 72 is the max. The minimum is 17.1. This is going to be a great cut, but if you're worried about it, go ahead and slow it down. You will listen to it, let your ear be the guide. If it's sounding good, increase the cut. I'm leaving 5/1000ths for the walls. I'm actually going all the way through or past the bottom here. As you can see, my levels were set at the top and the bottom, and I'm doing an extra 10 here. But let's go ahead and turn on that toolpath so we can take a look at it. So we're doing a series of arcs in there. We're doing things like a high feed rate, an arc off, high feed rate. If you have a bottom face, you can helical up off the floor, high feed rate over helical back onto the floor. I'm going all the way through it, so it doesn't really matter in this particular case. But iMachining is really revolutionizing the way you cut. This is a simple preview of what it does, but if you're talking about bulk material removal, exotic materials, or tiny tools, that's where it's really going to shine. Now, if this were anything harder, like titanium or any kind of steel, I'd still want to use iMachining even on a small cut like this. So it's a huge deal, and I'd love to give you a more detailed look at this. If you want to get into a demonstration, we can check out your parts, and we can do our parts, and I can get more into how well this works in a lot of different environments. Now, you can use iMachining in 2, 3, 4, 5-axis mill turn and Swiss, even turning. As you can see, I have a few more down here as well. Now, in order to make complex machines like mill turn and Swiss cohesive, we'll need to utilize our MCOs. Now, in MCOs, you can see these are what they look like here. They look like a toolpath, but they're technically non-toolpath cutting, and that's the way I like to describe them. But you'll come down here when you're done programming the first half of the part, and you'll come into MCOs. You can think of them as a macro as well, but these are all going to be set up for you for any given post. And you're going to put in for a transfer on this machine, you're going to start with the main spindle transfer start, the main spindle transfer end. You're going to put in a actual cutoff toolpath, and then a sub-spindle transfer start and a sub-spindle transfer end, which is what you're seeing. Now, before that, I also put in this B-axis reset to get it out of the way. Now, inside each one of the MCOs, when you add it, you're going to have parameters that you can adjust. Now, some of them don't have parameters like this one, so that's, you just simply add it. You need it to be there. It's going to show the correct movements of the machine, but it's also going to put in the correct code. I don't believe there's any information for the sub-spindle as well, but just to show you, let's go into the sub-spindle parameters and just see what we have here. So we have an RPM must match main at 300 start. We have a rapid to point pre-position, a pickoff point, and and pickup feed. Okay, so if we want to see what those are, let's go to the pre-position right here. If I click on it, you're going to see that sub-spindle move up to that pre-position. This is too close, so we're going to back that off a little bit. So I'm going to wrap it up to about this point, paste that value in there. I wonder what 1 inch would look like. Let's do that. That's fine. And then the pickup location where we're going to actually clamp. Now, this is where I could pull up, sorry, let me scroll this over a little bit and pick up a setup location. Or you can simply pick here and move the part onto where you want it to be. And that's going to be your Z2 again. I'm too far. Let's go up to here about somewhere in this neighborhood, and we'll go ahead and paste that value in as well. So that is how you set up your positioning of grabbing the part, and you hit save and calculate, and you're set and you're good to go. Now, what's really neat is that every one of our tool paths, whether that be a single tool path like a face mill operation or a milling, you can create a template and give it a name. You can say what machine it's for, the tools you're using, select OK, and it's going to show up as an operation over here that you can get to and drag to that face for any future part. So all the tools, the feeds and speeds, all that information will be there. But you can also do that for multiple ones. So I can take all of this and I can say, let's create a process template. I've already got one, but we'll go ahead and save it over the top of it. So now the next time I do a job and I get done with programming everything on the main spindle, I can come to the last operation, right click, or actually come over here and grab this. If I hover over it, you can see it says drag to the cam tree. I can drag it over to here. It's going to drop all of these in here for me, including the part cut off. And then I change a couple parameters in there, save and calculate, and I start programming for the sub spindle. I did a little turning on the sub spindle, by the way, and then some more eye machining for that pocket and these feet out here. Then you're going to do a part eject. This is very important because this is a two-channel machine. I need to add another piece to the sub spindle so we can sync up the two channels. So that's going to be important to put in there. But that literally for this machine is all I have to do. That process looks pretty much identical for any other machine that you're doing. You're going to have a start. In some machines, you might have a start code for that machine. Our start code happens to be right here in the machine options. Okay, but some machines are built with an MCO that you start with that does the cutoff and sets a 0 point. Then you program, as I've shown you here, you put in its transfer MCOs, program again, and do a part eject. Now, once you've done that, you have the ability to get to the setup and do channel syncing. To get to channel syncing, you can right click and go to channel sync down here. You can also come up to the ribbon and do channel syncing from here. Now, channel sync might come in looking a little weird. You may not know what you're looking at. Just come down here and show all and equalize everything. I'm going to make this look more of a raw format. You could come in looking like this with a bunch of, these are your primary weight codes that are going to be in here. For citizens, you'll have your 600s, your 610s, 620, 650s in here. I don't really have anything in here for this particular machine. But let's start right here, which I would call raw. Okay, nothing's been done to it yet. I just kind of prettied it up, made it very viewable. You got channel 1 here, channel 2 here, and we're going to export out to raw, and I'm going to call it raw. And right off the bat, let's just look at this, 12 minutes, 25 seconds. Now, there are 4 buttons I always click that get me well into the 90th percentile of being synced up. And there may be another few drag and drops here or there for adjustments. So those 4 clicks that I do is I kill all the temporary weight codes, or the primary weight codes, sorry, and then show the synchronization in the way that I programmed it, in the cam operation order. So that's what it looks like. We haven't synced anything up yet, so we're still at 1225. Now, that's after 2 buttons. That's killing all the weight codes and syncing it as in the cam tree order. I'm going to go ahead and output that as linear, I call it. The next 2 buttons, you're going to start by going to the first operation on the sub spindle side, and this won't even show up if you haven't done a part eject, so you're going to want to do that. Now, you can add a workpiece here, or you can add a workpiece up here, and it's going to throw it to the top. Fourth and final thing, remove this weight code to get the setup at the top, and I am basically synced up now. Now, I can move stuff around, but you can see that, in fact, it came down to 1103, and then, of course, I can go ahead and save this out as synced. But I could do other things in here. Let's say we want these 2 operations to start at the same time. Maybe put a weight code above it. Maybe I can put the main spindle start. I'm just trying to get this down a little bit further if I can. Main spindle transfer start and the sub spindle transfer start. We'll go ahead and drag that down here. Still looks good. I don't have any class view. But if I do something that's going to crash like that, actually that doesn't crash it either. I'm actually good to go. But let's see if we can show something that might crash it. There it is. So I put that B-axis reset in with the part main spindle transfer setup, and my view came on that I'm actually crashing, and you can select it and see what the problem is. Now we already know what that is, so I'm going to go ahead and I can't do that, so I'm going to just put it back by doing a Control-Z. But I have synced up this part now, and that should go away actually. And by the way, this is a time view if you'd prefer to look at it that way. Some people do. I think it's a little more confusing for me. I prefer to look at it this way. Now you can color these turrets by an operation. You can color them by table, or you can color them by workpiece, just how you want to see it. Undo, redo, saving, importing, and exporting different versions of this. That's going to be your clash view. Then you have your deleting of your weight codes, and of course creating of them. Pretty simple in here. And like I said, you do those 4 different buttons that I show, and you're going to get 90% of the way there, maybe 100 like in this case. And I just dragged and dropped a little bit, and I got a few more seconds off of it. So we're going to go ahead and save that. And now we get to see all of the fruition of our work come into being using machine simulation. Now, I generally won't go into machine simulation on individual toolpaths because it takes a little bit longer to get in here, and I don't need to. I just want to usually verify that part and that particular toolpath to make sure it looks good and then move on. I may do a bunch of them together just to see where I'm at in that, but I generally am only going to go into machine sim towards the end. And like you saw in the very beginning, we can have up to 4 different views. We'll go ahead and do that again. So this view, maybe we'll just look at this from the front here, kind of an angled view. Maybe we'll look at this from underneath this time, maybe from this view so you can see it working. Sub spindle, we'll go about there somewhere, maybe like that. So we can see this is going to move over here and work on there. And of course, this will just kind of be everything from underneath, both spindles and synchronization working together. So we're going to make sure we see the back tooling block here in the main spindle. Let's go ahead and hit play. Let's run it at full speed. If we did everything okay, then we're going to see it running the way you would actually see it running in the machine. If there's any crashing or over travel limits or head collision, you're going to be notified of that right inside here, and you can correct it very easily and move on. Let's pull this up a little bit. You can see the leftover stock from the main operation. We're taking it all off here, but once it transfers, most of it's out except for this a little bit of it on the feet and on the underside. Now, down here, you've got a play bar. These are the different operations. You can see it playing. If there's a long one, like this is the 5-axis cut. This is a simple swarf cut there. But after this iMachining toolpath, it's going to start doing a 5-axis simultaneous surface cut on these crown valleys here. Yeah, it's kind of hard to see, so we'll zoom up there. We'll let this one play out, and then what I can do is I can slide this bar down here, or I can select the next operation so to see where we're at that point. You see this playing around. If there were any errors on this, like an over travel limit, we'd be notified of that. We can see this from over here too, from the top side. There we go. All right. Let that one play out, and then we'll just go to the next operation. Almost done. No errors. Looks really good. We're going to go ahead and just pause it for a second. Go to the next op. It's going to race down here to this next line, update the model, and then we can hit play again. I know that these are all going to be the same because I did a wrap around there. There's our wrapping on the column that we did. And let's go ahead and go to the end of that as well. We have incredible graphics, and this is throughout the entire system. So it's going to be very easy because it's visual. You can move your tools around, adjust things all visually rather than just typing in numbers in, maybe or maybe not, getting them right. As you saw, that was the transfer. I'll do that again. I'll pull it back a little bit, go to the next stop, and we'll slow it down a little bit and play. Cut. Did you see that? Just one more time. You'll see it do a cutoff after it grabs it with the sub spindle. Look at the lower right-hand corner, cut off, and pull it back, and you're ready for another part. Go drop off this one and feed that bar out and continue on. Let's pull this up here. So now we can generate our code and our setup sheets and send that to the floor for operation. Let's start with our G code. This is a 2-channel machine, but it will show in 1 channel. A lot of other ones will split it up into 2 channels. The actual controller will split that up automatically, so it's all in 1 G code file for the Nomura, or for this particular one for sure. We're going to open that up in Simco, a very popular editor. As you can see, this is all the code for the Nomura. Let's bring this down. How many lines do we have? It's quite a few. Yeah, there's some stuff. And then if we come all the way down, we're looking at 39,153 lines. Can you imagine writing all that by hand? That's just insane. And yet, a lot of Swiss guys do write a lot of this by hand. They might take a little bit in the CAM and produce some toolpath, and then they copy it in here. But there's a lot of copy and pasting for a lot of Swiss people out there. You can save that or send it to the machine. Last but not least, maybe create a setup sheet. Now we have, you can capture images, put the part in a specific location and take a snapshot of it, and you can talk about it later. But we can generate 4 different types of documents here for your setup sheets: a docx, HTML, rich text format, or Excel. That's my preference. So we're going to go ahead and generate an Excel spreadsheet. Now this is going to give you all the information about this job, you know, where the coordinate systems are. This is for any job you're doing, not just Swiss, but your tools, your holders, your length offsets, your travel limits, your individual cycle times, overall cycle time. And again, like everything in our system, everything is editable by you. We do not lock this down. And there are a lot of formats that you can choose from that we've already created. This is just the stock one. I didn't add or subtract anything from it. Also, if you don't have Excel and you want to use it, I have found that if you don't have Office on your system and you generate an Excel spreadsheet, at least in my Windows 10 and 11, it went out and found a viewer for me and downloaded it so I could look at it. So this is what our setup sheet looks like here, or one of them anyway. Put in your own logos here. These are just variables you can interchange with other variables. Your travel limits, cycle time, information about your tools, maybe a hyperlink to the tool manufacturer. In fact, you can embed your own pictures, videos, or recordings in here in case you have some complex setup. Not necessarily for a Swiss, so it's pretty straightforward, but if you got something where you've got a lot of fixturing that you have to put together and do different setups in, say, a 3-axis machine, you could videotape your setups and narrate it and then embed it right into the setup sheet here. Of course, these are your operations. Operational notes will show up here, but like I said, you can embed all the other stuff right here if you'd like. And if you had fixturings and fixturing and other items, you can have them automatically pop in here as well, so you can see what's happening. Now you can send this to the floor, and if you're not the one setting up the machine, the guy that or the girl that's doing it, you would be able to send this to them and they can do that. Well, that's about all I have for you guys today. So let's head over to our questions and see what we have.
All right, thank you so much, Darrin. We will now move over to the Q&A section of this presentation. As a reminder, if you have any questions, please be sure to put them into the new tab under the Q&A on the right side of your screen. All right, let's get started then. So Darrin, other than Inventor or SolidWorks, are you planning on running inside any other solid modelers?
Yes, and I'm almost reluctant to say because I'm not sure if I'm allowed, but I'm going to go ahead and say it, and I'll work with getting in trouble later. We are currently working on integrating with Solid Edge right now, and I know there's going to be others, but that is what we're currently working on right now.
Sure. And then, so one of our viewers, I'm guessing, saw that there was a lot of, despite the SolidWorks branding, this is a lot of into SolidCAM. So do you need a SolidWorks license to get this to work?
You do need a SolidWorks seat. So we can install an inside of any SolidWorks seat. So if you already have some, you can install just an integrated one just to pop it in there. But we can also bundle it together with the SolidWorks seat as well. But yes, you do need Inventor or SolidWorks in order to run this. Now, we do have a shop floor editor that can be set up without SolidWorks. It doesn't create toolpath, but it will manipulate toolpath. You can edit the toolpath. You can change. The only thing you can't do is simply create a toolpath. You can verify. You can generate code. You can change the toolpath. So that particular piece you can put down by the machine for the controller or for the programmer in case he needs to adjust anything on the program.
Sure. Okay. And then how many channels can SolidCAM support?
Well, that's an interesting question. We haven't found the limit yet. I believe over in Germany, we've already programmed for a 6-axis machine. I believe Eric, and he may have more information on this. He's done 3 and 4 channel machines. So the way our architecture is set up is to be unlimited. So will we find a limit? I don't know. I don't think so. But as of right now, at least 6 channels.
Sure. And we have a few clarification questions here. So, for example, are MCOs visible within the machine simulation?
Yes, they are actually going to be showing the machines moving according to that machine simulation, or to the MCO, sorry. Yeah, those are very crucial. They do 2 main things. They show the proper movement of the machine, and they generate the correct code. Very important.
Of course. And can superimposition be programmed? And if so, how?
I believe that's on a Citizen. I think that's a 650, something like that. And yes, that's done with the MCO again.
Sure. And now, so the machine you were demoing all this on was a Swiss style machine. But
Correct.
for lathes that have live tooling, but maybe aren't quite as advanced as a Swiss, for example, one with a y-axis, another with a positional b-axis, how does this software support this type of machine configuration?
Well, the way I like to categorize Swiss is really just a more advanced mill turn, but on smaller parts. So it works almost identical. Now, the difference would be a little bit in the setup, and that's it. You're going to use the same MCOs, but the setup, you might have a 5C collet or a 3-jaw chuck or something like that on your main and your sub. Other than those, it's pretty much programmed exactly the same.
Sure. And we have another question. So the machine simulation within SolidCAM looks a lot different from what they've really seen inside CAM before. Can we fully trust this simulation and just not use G-code simulation?
Now that's a really good question, because you have G-code simulators. They require a reverse post in order to work, and that simulation from the G-code is only as good as the reverse post that's interpreting the G-code to the machine simulation. We have a similar situation in here. We're going off of the apt.cl file, but our simulation is going to be based off of that, but it's also going to be based off of how good our MCOs are and the post. So there's always an intermediate process in between, and that is what makes either G-code or apt.cl verification good. Now, if you have both, that's even better. So pretty accurate. I wouldn't say it's perfect. I wouldn't say G-code verification is perfect either, though. Hope that answers the question.
Of course. And I think we have time for one final question. So is there a list of the post processors available for SolidCAM?
Ooh, that is a question for Eric. Eric Forwith is the one that wrote this Nomura. Maybe if Eric wants to unmute, he could answer that.
So we do not have a formal list per se of what we have and haven't done yet. But I can say with the utmost confidence that there's not a machine that we've come across that we haven't been able to figure out for the most part. So we do have a vast library, but we don't necessarily have a database that customers can pull from.
And part of the reason is that I think I mentioned in the beginning, maybe I didn't. We post our post writers, they're writing custom posts for the given machine for a given purpose. Actually, this particular post has a couple of different flavors at least. One's written specifically for the machine, so he has to do very little work. Another one's written for somebody else like me that might want to take it and show it to people how to work it, because he can put in extra MCOs for certain items. This particular post was originally written for a guy doing this particular machine on one part, and that's all he's ever going to run. So Eric really set this up to be nearly you don't have to touch it. You can just do your programming, put in your MCOs, and you're done. There's nothing really to fill out. Is that an accurate statement, Eric?
Yeah.
Okay. We don't believe in out of the box certified, quote unquote, certified posts. Not that we don't have some, but we do recognize that most machines, most people, they want to see code a certain way. They want their post to work a certain way. So that's why we have a lot of in-house post writers. Eric is an amazing post writer, knows a lot about Swiss in Milturn. So that's his main focus, but we have people focused on 2, 3, 4, 5, and then many people actually focused on Milturn and Swiss, because that is a big niche right now. Well, it's not even a niche anymore. It's the main programming now. Hope that answers that question.
Sure, and thank you so much, Darrin and Eric. I'm afraid we are coming up on time here. So if anyone has any further questions, please feel free to reach out to Darrin and the SolidCAM team. Shortly, we will have this presentation available for on-demand viewing. If you need to review any of the videos that came up during this presentation, you should be able to watch it there. Thank you so much, everyone, for taking your time with us today, and have a great rest of your afternoon.
Thank you.